So I'm the next presenter. I'll be talking to you about our research on blue carbon and how it actually fits into a certain pattern over in the Indo-Pacific tropical seagrass meadows. So I'd just like to begin with showing you a familiar map for those who are in the blue carbon arena. So these are data points contributing to seagrass blue carbon studies as of 2012. And I took this from Fakrin et al. 2012, which is still the primary research for blue carbon up till today. So one of the main take-homes from this paper are the figures that I've highlighted in red. The global seagrass organic carbon stocks range from 115 to 829 megagrams carbon per hectare, and global stocks ranges from 329 megagrams organic carbon per hectare. So my studies range from the Mediterranean all the way to South Australia, to the Australian continent. Shout out to Professor Paul Lavery, who brought me into this area since 2010. And I'm trying to continue on with this in Southeast Asia, specifically in Malaysia. So one of the drivers of blue carbon research globally is trying to find a set of predictors on estimating the seagrass stocks, seagrass carbon stocks in the sediment, but as far it's still pretty elusive. So to provide context for organic carbon stocks here, I refer to the carbon buried in the sediments. So if it's still elusive for estimating or for predicting carbon stocks globally, would it then fit into a certain pattern for blue carbon sequestration in the Indo-Pacific bioregion? So one of the lead up to it is obviously there are similar meadow characteristics in seagrass meadows all over in this area, composing of families from these seagrasses from these families. So with that, I brought seagrass research to Malaysia to see how much carbon is sequestered in the seagrass meadows of the Sungai Pulai Estuary and the Pulau Tinggi Marine Park. The Sungai Pulai Estuary is a highly disturbed seagrass meadow. Ongoing development activities are occurring, from port construction to dredging to reclamation. And the opposite is happening in the Pulau Tinggi Marine Park. It's basically a marine protected area, and it forms one of the important seagrass meadows in Malaysia, constituting a dugong feeding ground in this part of the country. So a simple hypothesis that I tested was, are there higher carbon stocks in an MPA compared to a disturbed area, or rather a non-MPA area? So we use standard methods to quantify the organic carbon stocks. We looked at organic carbon provenances, the sources, through a 4-source mixing model by using stable isotope signatures. So these are the results that we got. Clearly, the estuarine seagrass meadows contain more carbon compared to the marine park, ranging from 140 megagrams carbon per hectare compared to approximately 40 megagrams carbon per hectare for the marine park area. We looked at the sediment provenances based on sediment layers, the superficial layers up to 30 centimeters, and from 30 centimeters up to 100 centimeters for deeper sediments. So the provenance or the source signatures for seagrass-derived organic carbon is about approximately 10% for superficial sediments. For deeper sediments, it's about half of that. And I apply the same method to the seagrass cores collected from the marine park. They are much higher in proportion, up to 27.4% for superficial sediments, and again half of that for deeper sediments. So clearly, our hypothesis did not fall through, whereupon seagrass carbon stocks in an MPA is not necessarily higher than in a non-MPA. So the other thing would be the non-seagrass derived or alternate inputs assisted in contributing to bulk organic carbon in seagrass sediments. So how does this all place in context for Indo-Pacific blue carbon in seagrass meadows? So what I have done here is I have taken recent papers from 2012 to probably earlier this year. These are by no means extensive, but a lot of published papers quantified the carbon stocks in a similar unit, so it was easy to compare. So we got data from the eastern side of Africa all the way to southern China up to northern part of Australia, tropical Australia. The red bars are maximum organic carbon stocks for that particular location where I got the data from, and the blue are the means of that particular area. So clearly, the overall trend that I can see, or we can see so far, is that all the seagrass meadows in the Indo-Pacific region, to date anyway, do not have seagrass carbon, sediment organic carbon beyond the global average of 329 megagrams organic carbon per hectare. So the other thing will be that, and all the other studies which look into provenances was never above 50% seagrass derived organic carbon, and this 50% is by the estimate provided by Kennedy et al. 2010. And the two dots there are the studies that I've talked about earlier. So to date, what I've done is I've pretty much taken a reductionist approach, whereupon the first point to note would be generalizations on the high capacity for carbon storage in seagrass meadows can be misleading. This is a statement that I would like to impress first and foremost, because I've been talking to marine park managers where there is an assumption that marine protected areas with seagrass meadows will automatically qualify with a high carbon stock area, and that's not necessarily the case. In my own words, I think seagrass stocks in this bioregion are modest. It's unlikely to have stocks beyond the global average with the current set of data anyway. I'm happy to be proved wrong if any of you find any other, or find research or do studies which prove otherwise. And some of the directions that I would suggest would be looking into mechanisms for carbon cycling and stabilization in seagrass sediments. Basically, that's all that I have to say, and thank you for your time. And I'm open for questions. Yeah, Barry.
I more or less know what you're up to. We're both working in Malaysia.
Right.
And I'm working in Borneo. Something about the last speaker said about hotspots. You know, one of the problems is representative sampling in an area, and you know that the work on the estuary to very muddy, callous, solid loading tend to bear out that actually quite a lot of organic carbon. So I guess the question, which I know I managed to answer, have you any feeling about what is the proportion of coverage of seagrass in more open coastal systems, like the one you're studying, the ones which are in essentially highly muddy estuaries where, and callous can actually handle a lot of turbid environments and continue to trap stocks. Is there any data on the area? Very little data on areas, basically.
Right. Yes, I agree that could be a way forward for understanding carbon sequestration in the region. More often, the carbon sequestration or even the existence of seagrass meadows are usually intertidal. We don't know much of subtidal areas in this region. And that's I totally agree that that's a way forward for looking into this area.
So one of the areas is finding areas in which
Yeah.
all the non-seagrass
Yeah.
survey stuff. It's not being done.
That's right. Yeah.
You can give per hectare, but what does it mean?
Yeah, sure.
So perhaps a follow-up question. So if you would compare the MPA, the carbon surface just outside the MPA, what would you expect to find?
I would expect to find probably even less seagrass-derived organic carbon sequestered in lieu of its existence without any seagrasses. That's my primary suspicion. I mean, we can talk about export to those other locations outside the MPA. And on the assumption that outside the MPA, there's no other seagrass meadows at all. Even I'm falling back to what Barry said earlier. There's just such a huge knowledge gap on just the existence of seagrasses. So it's again another way forward. Okay, so if there's no more questions, thank you for listening. I